Hello everyone, welcome to a new video of Physmatica. Before we start, please don't forget to like and subscribe. This is the solution for the second week's problem. This is a physics problem. If you're an undergraduate in physics, you need to know how to solve this type of problems very quickly. It's a simple harmonic motion and we want to find the total mechanical energy. So, first let's take a look at the equation for the total mechanical energy of a harmonic motion. So we know that it's equal to 1 over 2 mass multiplied by angular frequency to the power of 2 multiplied by amplitude to the power of 2. So we had the mass from the question itself, which is 50 gram. I'm just going to change everything to SI unit, and we can also simply find the amplitude from this position time graph, so which is 4. I'm going to change that to the SI unit as well. And from here, we see that the only thing that we don't have to find the total energy is angular frequency. So that's the challenge of the problem, and we want to find a way to find the angular frequency based on the data that we have. So there are multiple ways you can solve this. The best way, and this is the way from any physics book that you open, and this problem is from a holiday book, Holiday Physics. So we know that displacement equals A multiplied by cosine omega t, which is just simply an equation for the displacement in a harmonic motion or harmonic oscillator. So simply said, for that position of -2, if you take a look at the graph again, you can see that on the position of -2, our t equals 2 over 15. So let's just solve this equation for that specific time and position. We have -2 equals 4 cosine 2 omega over 15. And from here, we can see that cosine 2 omega over 15 equals -1 over 2. What are the angles that their cosine is going to be -1 over 2? Simply said, in that arc or in that harmonic motion that we're in, it's going to be 2 pi over 3 and 4 pi over 3. But which one we can accept? Simply say, you can just do the substitution and calculate it, but simply said, if you take a look at the graph again, you can simply see that 2 pi over 3 is actually a previous time, so we cannot accept that, and we can accept only 4 pi over 3. So let's just substitute. We get that 2 omega over 15 equals 4 pi over 3. We solve for omega, and our omega is 10p. We have everything. Now it's just a simple substitution, and our total energy equals 4 multiplied by 10 to the power of -2. This is the best way you can solve this type of problem, and even if it's a bit more complex and more tricky, still this is a way to find the angular momentum or time, whatever your unknown is. But if you're on a, for example, a multiple questioner problem and you want to save some time, there is another way. There is multiple ways again, but this is quite fast, and the idea is that you can just simply find a period. If you can connect how the movement is done on a circle of motion, so we know that angular frequency equals 2 pi over t, which t is the period, and we simply want to find a period now. So the movement is from 4 to 0, from 0 to -4, and -4 to -2. If you take a look at the arcs that we are just passing, we can simply see that it's t over 4 plus t over 4 plus t over 6 equals that specific time, which is 2 over 15. And if we solve for t, we get period is equal 1 over 5. And simply said, again, our angular frequency is 10p. This is a bit faster. If you would like to save some time, I hope you like the problem. Thank you so much. See you next time. Bye.